Right, next we start nitric acid. So nitric acid is also a volatile acid. So to prepare nitric acid, which is a volatile acid, here also we use a non-volatile acid like sulfuric acid and a salt of nitric acid. That is either sodium nitrate or potassium nitrate. So in this glass apparatus, which is called a retort, you are taking the mixture of concentrated sulfuric acid and sodium nitrate. Or instead of sodium nitrate, we can take potassium nitrate as well. And when you heat it, it produces nitric acid vapors in this glass apparatus. So these nitric acid vapors will be passed into this round bottom flask here, and a cold water is poured onto this round bottom flask so that the vapors of nitric acid will be condensed to give liquid nitric acid. And this is the reaction which is taking place in this process, that is potassium nitrate plus concentrated sulfuric acid, or you may take sodium nitrate plus concentrated nitric acid. And when here we have to use the temperature which is less than 200 degrees Celsius, the reason is same as in case of HCl. It is to save fuel. At the same time, nitric acid is sensitive to high temperatures. That means when you heat nitric acid, it undergoes decomposition. So that's why it's better to have low temperatures in the preparation of nitric acid. So the reactants will be potassium nitrate or sodium nitrate along with concentrated sulfuric acid. So here nitric acid is a volatile acid and sulfuric acid is a non-volatile acid. So this non-volatile acid can displace a volatile acid from their salt. Next, the precautions: one is temperature should be below 200 degrees Celsius, and the second precaution is the entire apparatus has to be made of glass only. So all glass apparatus has to be used. You cannot use anything like which is made up of rubber or cork, because the reason is the nitric acid vapors are highly corrosive and they can destroy rubber or cork, but glass is unaffected by the nitric acid vapors. So that is the reason glass apparatus is used in this case. And since nitric acid is unstable to high temperatures, even you maintain a low temperature which is less than 200 degrees Celsius, a small quantity of nitric acid undergoes decomposition, which will give you reddish brown nitrogen dioxide gas, which remains dissolved in this nitric acid, which dissolves in nitric acid. So this will give yellow color to the nitric acid. So this is when you prepare nitric acid in the lab method. So this happens because nitric acid is sensitive to heat and it undergoes decomposition to give reddish brown nitrogen dioxide, which remains dissolved in nitric acid, and it gives yellow color to the nitric acid. And this yellow color can be removed in two methods. Either one, it is bubbling of air or carbon dioxide, means when you send air or carbon dioxide, so that will take that nitrogen down with them and comes out. That is one method. Or by dilution with water. So when you dilute the yellow color nitric acid with water along with oxygen, so that nitrogen dioxide will be converted to nitric acid. So in that way you can remove nitrogen dioxide gas. Next, identification test for nitric acid. So when you take this nitric acid vapors and condense it, and when you heat it along with copper metal, it releases reddish brown vapors. And the next one is preparation of nitric acid in industrial process, that is Ostwald's process. So in this there are three steps: step 1, step 2, step 3. So in step 1 you are going to oxidize ammonia in presence of oxygen with a catalyst platinum, and it gives nitric oxide as a product, and the reaction is exothermic. Reaction is exothermic. So since it is exothermic reaction, so only the reaction mixture is heated initially, and once the reaction starts you don't need to heat it from external, so automatically the heat produced within the reaction will be sufficient to carry out or go forward. And in the second step, the nitric oxide is again oxidized to give nitrogen dioxide. So second step of this industrial process also oxidation. So in this you will get nitrogen dioxide. First step you are getting nitric oxide. Second step it is converted to oxidize it to nitrogen dioxide, and then coming to the third step. In third step nitrogen dioxide is converted to nitric acid by treating with water and oxygen. So even this is also an oxidation process. So in this method all three steps involve oxidation. So that's why in this reaction you will take excess oxygen. Excess oxygen is taken in this method, that is Ostwald's process, because all three steps involve oxidation process. Then reactions of nitric acid. First one is thermal decomposition. Thermal decomposition of nitric acid. So this is the decomposition of nitric acid, which will give you nitrogen dioxide, water and oxygen. Then nitric acid acts as a strong oxidizing agent. Whether you take dilute or concentrated, both the forms, nitric acid is a strong oxidizing agent, because whether it is dilute or concentrated, in both the cases nitric acid gives oxygen atoms. Nitric acid produces nascent oxygen atoms, whether you take dilute or hot dilute or concentrated nitric acid. So in both the forms nitric acid acts as a good or a strong oxidizing agent. And we have only specific reactions, that is with one carbon, sulfur and copper. With carbon, when you treat nitric acid, the carbon will be oxidized. Carbon will be oxidized to give carbon dioxide. Sulfur will be oxidized to give sulfuric acid, and copper is oxidized to give copper nitrate. And in all these cases, since you are using concentrated nitric acid, so in all these three cases you will get nitrogen dioxide as a product. So for this the observation will be reddish brown vapors. Then dilute cold nitric acid, when reacts with copper, it gives copper nitrate and nitric oxide. So if it is concentrated nitric acid, the gas produced is nitrogen dioxide. If it is the gas produced is, and the mixture of concentrated nitric acid and concentrated HCl in the ratio 1:3 is called aqua regia, and this aqua regia is used to dissolve gold or platinum, because this aqua regia will give you nascent chlorine atoms, which is highly reactive. Nascent chlorine is highly reactive and that can oxidize the noble metals like gold and platinum also. So this is the reaction where platinum and gold can react with chlorine and they form respective chlorides. Then brown ring test. The brown ring test is for the identification of nitrate ion. So this is another chemical test which is very important. So to any solution which contains nitrate ion, or if you take a dilute nitric acid, and when you add ferrous sulfate, freshly prepared ferrous sulfate to this nitrate solution or nitric acid solution, and then if you add concentrated sulfuric acid, so then it forms a brown ring test. So when you take dilute nitric acid or any nitrate ion, first you are adding freshly prepared ferrous sulfate followed by concentrated sulfuric acid, then it forms a brown ring. So which is a confirmatory test for nitrate ion or nitric acid. Okay, so in this case freshly prepared ferrous sulfate is used because we need ferrous ions. Otherwise, the ferrous ions will get oxidized to ferric, which is not useful in this test. So, which does not the brown ring. So, these are some important points related to the nitric acid.